Hello, calculus students and seekers of truth. In this video, we will look at an example of the second derivative in parametric mode. And you see here, I have x in terms of t, that's cosine of t. Y, this is a 3t cubed minus square root of t. So this is the same as the equation that we worked with before. I'm going to call this equation f of t, this one g of t. If I take the derivative of x, I get negative sine. Right? So the derivative of y, I get 9t squared minus 1 over 2 square root of t. All right, now let's go a little bit further, right? So if I want to find the derivative of y with respect to x, it's dy dt. This is what I had before. 9t squared minus 1 over 2 root t. All of this over dx dt, negative sine of t. Okay. All right, so now if I want to take the second derivative of y with respect to x, but give the answer in terms of t, I like to look at it this way. I like to say that this is big F of x, and this is all the same over here. So if I want to take the derivative of both sides with respect to t, if I want to take like d dt of the whole thing, then on the left side, I'm going to get f double prime of x. Remember, x here is a function, so I have to multiply that by the derivative of that function, which is little f prime of t. And all of that is equal to the derivative on the right side of the equation here. And yes, unfortunately, it's unavoidable that we're going to have to work with the quotient rule in this case. So we're going to take the derivative of the right side here. So that's the derivative of the top, which is 18t squared minus, and you can think of this as negative 1/2 t to the negative 1/2. So this becomes positive 1/4 t to the negative 3/2. That's the derivative of the top times the bottom minus the derivative of the bottom, which is negative cosine. So minus negative cosine, that's the same thing as positive cosine, times the derivative of the top. Sorry, times the top, not the derivative of the top. All of this over the bottom squared. So negative sine of t squared, so that's just sine squared of t. Okay? Then I have to go one step further. I have to go one step further by dividing both sides by little f prime of t. So I get f double prime of x is equal to this big mess over here divided by little f prime. Now, little f prime, mercifully, is just the derivative of cosine, so that's negative sine. So I'm going to write this whole thing here one more time, 18t squared plus 1/4 t to the negative 3/2 times the negative sine of t plus the cosine of t times 9t squared minus 1 over 2 root t. All of this over sine squared and then divided by negative sine squared. So negative sine cubed t. All right. There is a way that we can simplify this. It's probably cruel and unusual to make you simplify this, so we can probably stop right here. But I think you get the idea of the complexity of these problems. Okay. And in order for us to get an answer like this, dy, the second derivative of y with respect to x in terms of t, notice here the problem that's being framed here is that I want to find this answer when t equals 4. Okay? So when t equals 4, all I have to do now is take 4 and plug it all into this big equation and get my answer. Okay? And it's not really something that you could really do if you try to do this with eliminating the parameter, at least in this case. If you try to do something like cosine inverse of x is equal to, cosine inverse of x is equal to t, and then plug it in here, you still have to figure out what, you can't eliminate the parameter because the parameter is a part of finding the answer. Okay, so this is part of the reason why we have to deal with these large complex problems when we're working with parametric equation, is because most of the time the answer is given to us, or the problem is framed to us in terms of the parameter itself. All right, as always, thank you for watching. Always ask for help if you need it. Keep working hard and have a wonderful day.